video I am going to explain the project presentation. The project title is Smart Home Automation System. It is totally based on IOT, Intelligent Home Control Project. The internship is Internet of Things, organized by Emertxe Information Technologies and presented by D. Likita. First, we have to know what is the meaning of IoT and where does it work. IoT abbreviation is Internet of Things. In the name only we have the Internet. So the Internet of Things refer to the network of physical devices, sensors and applications connected to the Internet, enabling them to collect or exchange and act on data without any human interactions. In IoT systems, devices can communicate with each other and with users remotely, allowing real-time monitoring and control and automations. Common examples are including small home devices, wearable health monitors and industrial sensors. In smart home communication project, IoT enables user to control light, fan and other applications via mobile apps and improving conversions, energy efficiency and security. This is the short project overview. The smart home automation system is designed to remotely control and monitor garden light and temperature and water tank values using Arduino Uno for the software, and PICSimLab is the hardware based, and the BlinkApp mobile applications where we control those applications. The Arduino Uno is programmed through the Arduino IDE and simulated in PICSimLab to present hardware components like relay sensors and actuators. The ESP8266 is the Wi-Fi modulo enable communication between Arduino and Blink cloud server, allowing users to control devices such as garden light, regulated water inlet and outlet valves, and monitor temperature directly from their smartphones. In this project, we use the BlinkApp for the replacement of the smartphones. This project provides a user-friendly, cost-effective and efficient solution for smart home and garden management, improving convenience, energy efficiency and automated control of household system. This is the short objective about this project: to remotely control and monitor garden light temperature and water tank value using Arduino Uno and BlinkApp. The operation of devices based on sensor readings such as a turning a light at night or controlling water flow automatically. To improve convenience, energy efficiency and safety in home garden management. To provide a cost-effective and user-friendly smart home solution for using IoT technologies and hardware simulation in PICSimLab. This is the block diagram of this project. We use the Arduino IDE here, and hardware generation is done in the PICSimLab. It is a replacement for the hardware, and by controlling system is done by the BlinkApp, where we control BlinkApp by using our mobile only. We can see the output in PICSimLab, and the software means coding is done in the Arduino Uno. We control the garden light controlling like LEDs we use for this garden light controller, and temperature controller. Temperature control we can see in LCDs, and water tank controller. This is the work principle. Here I choose the example for the water tank, similar for the temperature and garden lights. We use the Blink IoT app and Arduino IDE. I already explained in the block diagram only. By using this, we can see the volume of the water and inlet water. And this is the software requirement. We use the three software for this project. First one is Arduino IDE for the coding purpose, and PICSimLab, it is the replacement of the hardware, and BlinkUp where we control those applications. Arduino IDE, use it to write and upload programs like sketches to the Arduino Uno, and supports C, C++ programming and communicate with hardware modular like sensors, relays and Wi-Fi modular. PICSimLab, a hardware simulation software it is this, and we use it to the test and simulate circuits before actual implementations. For this project we can use it for our hardware only. There is no for actual implementation. This is the online project, so we can use this PICSimLab directly. Help in visualizing the operation of Arduino sensors and actuator without any physical components. This is the best one for this. And this is the BlinkUp. It is a mobile application for IoT control, enabling user to monitor and operate devices remotely. Connect with Arduino Wi-Fi ESP8266 modulo. This is the Wi-Fi modulo to provide real-time feedback and control for applications like light, waves and sensors. By using these three softwares only, the project of IoT is done. I am going to now code. So for coding purpose, I am going to use Arduino IDE. I already told about the slides. So I am opening the Arduino IDE. Wait a minute. IDE where we run the program coding here, and here I choose the board for the Arduino Uno, and the LDR, LDH and main.h serial thing. These are the new sketches, and here the entire controlling code is done by the home automation blink control.ino. Here only we write the code for the temperature and LED controlling and water tank wires, all are here. In this video I am not going for the explaining this code. The guidance of the Emertxe only share the code and give the instruction to us. The serial tank code is done by the here, and the header files all are done by the in.h. The temperature systems are done by the here, and the temperature header files are dot here. The main will guide this all this. So this is the coding. This code we can join in Emertxe, and the code guides only give us. Just I am going this and run this sketch and upload binary. You can see the compiling sketch. It's taking a minute, please wait. Once again I am not explaining the code. Our guides are give the entire classes in this code, so we just following them. Now you can see the output is done here. This is the Arduino IDE, and the software code is done by this only. The code, and now we are going to simulation part. For simulation part, and this is the PICSimLab. Here we can generate the file and loading X file, and we can see the X file, and we are going to running this automatic. It is can loaded. Now you can see the PICSimLab. This is running of the output, and we are opening the spacepads. Already I am loaded the file, so we can see the LCD. T for temperature and 27.34 is the temperature, and V for volume. We give the last 3K value for this, and you can see this, and this is the either and LDR and one LED and heater controller. The LDR will be controlled here. So many LDRs, I choose the only one for this, and it is the Ethernet which is connected to the Ethernet, and this is the spare part of the PICSimLab, our output generated. And here we can see the heater also. Here we all connected the heater on this. Wait a minute. Now you can see this is the output for the temperature, volume and all. The LDR all are connected. This is the spare part of the PICSimLab, and I connected the automation, and this is blink app application. Here we can created the two tabs also, you can see on the display. And this is one, and the tab 1 consists of the cooler and heater and temperature gauge. You can see the temperature same as per the spare part generated. And the blink app, this is home automation. And this is the volume serial tank temperature. I am turning on the heater, and you can see the temperature increasing only. And you can see the notifications also. Okay, I am turning off the heater, and you can see I am turning on the cooler. See, we are turning, and we are turning on the cooler only. And I am offing this, and in the tab 2 we can see all two more options, volumes and gauge also. The serial tank gauge we are turning on. You can see the volume of the serial tank is decreasing, and temperature also you can see. In the side you can see the cooler is off. And I am in the tab 1, you can see the notifications also. In the tab 2 again, you can, this is working as smoothly only, the temperature. Again in tab 2 I am just turning one only, and it is increasing, you can see. And it is increasing to 8, 2, 9 and 3. In the limit of the 3000, you can see the notification also. You can see right now, here it is the notification. After filling of the volume, you can wait this is the you can see the notification. This is full, you can turn off. And this is the project demonstration, the simulation. We are done with the simulation. And next, applications. I am just giving a small applications for this project where we can use this in our real time. For this project based on IoT, we can smart lighting system Philips X LIFS light can be controlled while apps, voice assistants or automatically based on time or presence. Smart thermostatics and temperature control. Nest Ecobee automatically adjust home temperature for comfort and energy efficiency. Automated irrigation and water management. Smart garden irrigation system and control water flow based on soil moisture and weather forecast. Home security and surveillance also done. Ring, Allo, Google Nest cameras monitor home remotely, receive alerts from motion detections. And smart applications are smart refrigerator, washing machines and coffee makers can be monitored or controlled while mobile apps only. Remote device controllers and voice assistants, Amazon Alexas. Now we all using this Amazon Alexa and Google Homes, like control multiple home devices at a time. Example, light, fans, waves. Already we have done this project on controlling lights and the heaters, so remotely or by voice commands. And energy management and monitoring, smart plugs and energy meters, like monitor power consumptions, schedule applications or reduce electricity bills. This is the real-time applications and based on this project of IoT. Next, we are going to give the conclusions. So this is a small conclusion about this project. The smart home automation system based on IoT using Arduino Uno, PICSimLab and Blink app provide a practical, cost-efficient, effective and user-friendly solution for remotely. By this, controlling and monitoring home devices is done by integrating sensors and relay and Wi-Fi connectivity. The system allows user to control garden light, monitor system, and operate water tank waves from anywhere via a smartphone. The project demonstrates the potential of IoT technology is enhancing, conveying energy efficiency and automation is in daily life. Using PICSimLab for hardware simulation, ensuring that the system can be tested and refined before real implementations, making it a reliable and scalable solution for the smart home applications. This is some future scopes. The smart home automation system based on IoT can be further enhanced and expanded in the following ways. Here I am going to give some future scopes. Integration with voice assistants, control device using Alexa. Already we see all this on applications, but we can use some future scopes also. Google Home and Siri for hands-free operations. Advanced sensor integrations are add soil moisture sensors, humidity sensors and smart energy meters from more efficiency, automation. And AI and machine learning are using AI to predict user behavior and optimize devices operation for energy saving and convenience. And mobile app enhancements are develop a dedicated app with notifications, scheduling and remote monitoring for the future beyond Blink. Scalability for entire smart homes, expand to control lighting, HVAC systems and security cameras and households applications for complete home automation we can take here. And cloud data analysis, store sensor data in the cloud for analytic performance and cracking a productivity maintenance. These are some future scopes about this project. And the last is thank you for this project and thank you.